Let us understand the terms consistent, inconsistent, and dependent. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have exam review for linear simultaneous equations. In previous video, we answered the first two questions, which is what do you understand by point of inflection and different methods to find point of intersection for a given system. So we used three different methods. One, using a graph. Second, using substitution method. And the third, using elimination. Now in this video, we'll answer the other two questions, which are: without solving, determine the number of solutions of each of the following systems. And then classify the linear system in question 3 in terms of consistent, inconsistent, and dependent systems. Now these three are technical terms: consistent, inconsistent, and dependent. We'll try to understand them. Okay, so let's begin with solution of question 3. Question 3 states, without solving, right, determine number of solutions. So let's begin with A, which gives us two equations. One of them is y equals to x plus 2. The other one is x plus y equals to 2. So let's call this as equation 1, and this is equation 2. What we will do is we'll isolate y in equation 2. So if I isolate y, I get y equals to minus x plus 2, which is equation 3. So now, if you compare these two equations, what do you see? Well, the slopes are different, right? They have different slopes. So if slopes are different, there is going to be one point of intersection, right? So there is one point of intersection, correct? So we need to just find the number of solutions. So number of solutions will be 1. So we have this one done. So we have one solution. So we have only one solution. Or exactly one is a better word, right? Now let's look into the second system, which is y equals to minus 2x plus 5, and we are given 4x plus 2y equals to 5. Now in this, we need to isolate y in the second part to check the slope. So taking 4x to the right side, we get 2y equals to minus 4x plus y. Dividing by 2, we get y equals to minus 2x plus 5 by 2. Now if you compare the given equation number 1 and second, which we changed in slope-intercept form, what do you see? They have same slope, but they have different y-intercept. See, the y-intercept is different, correct? So they have same slope, different y-intercept, right? So negative 2x is the slope. So what you'll see normally is that if you sketch these lines, y-intercept being 5.5 of 5, right? So negative 2x, one line will be like this. The other line will be like this. But they are both parallel, right? So we have parallel lines. No point of intersection. No solution. Let us summarize. Same slope with different intercepts, y-intercepts, means no solution. Well, in case you want to learn from me, you can always send an email on the address given. Most of my students are right there on top of their class getting awards and scholarships like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. So, there are zero number of solutions when the lines are parallel. That is, same slope, different y-intercepts. Now, let us take part C in the next page. Part C is, the two equations given to us are 2x minus 6y equals to 4 and y equals to 1/3 of x minus 2 by 3. To find the number of solutions, we have to really check two things, and that is slope and intercept, right? We are already given the second equation in slope-intercept form. Now, let us write the first equation in slope-intercept form, isolating y. So we get minus 6y equals to minus 2x plus 4. Dividing by minus 6, we get y equals to minus 2x divided by minus 6 plus 4 by minus 6, correct? So that gives us y equals to 1/3 of x, right? And here we get minus 2/3. So as you can see, both equations are exactly same, right? And that really means that we have infinite points of intersection. So these are the lines which are overlapping. So overlapping lines will have infinite points of intersection. Is that clear to you? Correct? So what we observed here is that we had 1 point of intersection for the first line, 0 for the other one, and infinite for the third one, right? Now let's define few more terms which are related with number of solutions and the linear systems as such, describing them in a different way. Question number 4 was classify the linear systems in question 3 in terms of consistent, inconsistent, and dependent. So let's try to understand these three terms. When we say consistent, it means what? Can you tell me? Consistent means has solution. So we had one solution here, no solution, and infinite solution. So these two are consistent. They have solution. Do you see that? And this becomes inconsistent. Now, when we have solution, in that case, we have a condition for infinite solution, right? So, dependent is the one where we have overlapping lines and infinite solutions. The other case is independent. So the first one is independent and the last one is dependent. So that is how we classify a system in terms of consistent, inconsistent, and dependent systems. Perfect. So I hope you have understood these strategies. So basically, we are looking at slope. If the slope is not equal, then we get one solution. But if the slopes are equal and the y-intercepts are not equal, then we have no solution. But in this case, we have slopes are also equal and intercepts are also equal. They are exactly same lines. Then we get a consistent dependent system. Is that clear to you? Perfect. So we can summarize the consistent understanding with the help of this diagram. So as I was saying, consistent system is one having unique solution. Dependent system not having unique solution, right? So when we have dependent means not unique. So more than one, right? Inconsistent means system having no solution. So that is how we define them. This is an example of consistent system which is independent. Here is two lines overlapping. So infinite solutions, consistent but dependent. No solution since the lines are parallel. Is that clear to you? And key to find how many points of how we really do it is different slopes. The systems will intersect at a point and will be consistent and independent. Same slope, line could be parallel or overlapping. Therefore, check for the y-intercept. Same y-intercept implies consistent and dependent lines are overlapping, resulting in infinite number of solutions, and different y-intercepts means that they are parallel with no solution. Perfect. So with this, we end our video, and I hope you have understood all the concepts regarding point of intersections and how do we work with them, right? So we come to an end of a set of 4 video questions based on point of inflection. In case you want to learn from me, you can always send an email on the address given. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.